Hello everyone, let us see next examples depend on the inverse Laplace transform formulas. Now 10th example is L inverse of, where to find out inverse Laplace transform, that means L inverse of. Question is same, find the inverse Laplace transform of. Okay, in short, everywhere we are writing like this only. Okay, somewhere in example also they can ask for such type of notations. L inverse, that means we have to find out inverse Laplace transform of this function. What is this function? 2s plus 1 upon this denominator. Okay, now we have to separate out just denominator, that is L inverse of 2s upon s square minus 4 plus 1 upon s square minus 4. Now take inverse L inverse inside the bracket, like derivative, like Laplace, like integration. Inverse Laplace also follows the linearity property. That's why L inverse gets inside to the each term, and ultimately we have to take constants outside. In this step, in this first term, 2 is a constant, take outside L inverse of s upon s square minus 4 plus 1 upon s square minus 4. Taking Laplace inverse of both the term, this inverse is of course numerator is yes, that's why it is cos. Denominator contains minus sign, that's why it is cos hyperbolic. Fourth root is 2t plus L inverse of this is sine hyperbolic, then 1 upon a. Formula for sine hyperbolic is 1 upon a. A means this fourth root, that is 2. Sine hyperbolic same angle 2t. This is the answer for this question. Now next question, we have to find out L inverse of this term. Whenever any term contain square, cube or power in this expression where addition of terms are there or subtraction, we have to first expand these terms by using square expansion or cube expansion. Okay, now here square expansion is there, a minus b bracket square we have to use, that is 3a square, that is 3s raised to 4 minus 2ab, that is 2a square plus 1 square is 1. Okay, divided by rest of the term. Now take this 3 by 3 inside, we get this term, and now separate out the numerator, we get 3s square s raised to 4 upon 2s raised to 5 minus this upon this plus 3 upon this raised 2 raised to 2 into s raised to 5. This is the we just simplified this term. Now take L inverse inside, and ultimately constants we have to take outside. That means 3 by 2 is a constant, take outside. 1 upon s inverse is 1. You can directly write this step, you can skip this step. Okay, minus 3 is outside, 1 upon s cube inverse is t raised to 3 minus 2, that is 2 upon same number 2 factorial, plus 3 by 2 1 upon s raised to 5 is t raised to 5 minus 4 1, that is 4 upon 4 factorial. Now simply this is the answer. Now simplify, 3 by 2 minus 3t square by 2 factorial is 2 plus 3 by 2 into 4 factorial is 4 into 3 into 2 multiply by 2, that is 48, t raised to 4 as it is. Okay, this is the how we can simplify first the given terms and then take the inverse Laplace transform. Now consider next this L inverse of this term. Numerator and denominator contains 16s square minus 25. Now take numerator, divide the numerator or separate out the numerator, we get 4s upon this denominator plus 15 upon this denominator. Now take L inverse inside and ultimately take constants outside. 4 is a constant in this term, take outside L inverse of this term as it is, plus 15 is outside L inverse of 1 upon 16s square minus 25. Now if you observe these two, of course this is a cos hyperbolic and this is sine hyperbolic, but whenever the denominator contains s square in every formula of L inverse Laplace transform, whether the denominator is s square everywhere, the constant of s square must be 1. Okay, for then only we can calculate the inverse. A square cannot be anything, it is a constant, doesn't matter whether it is integer or perfect square or a fraction, but this s square coefficient must be 1 to calculate the inverse. Okay, therefore in this example here 16s square minus 25, we must do this s square coefficient 1. For that, logically this 16 take outside. Okay, we have to take whatever the number attached to s square, we have to take common from the denominator. Here also same thing, we have to take common. Next step, we have to take common 16 outside, which is a constant. That's why we can take outside of L inverse also. And here 25 by 16, here also 25 by 16. Okay, therefore this term becomes 4 upon this 16 gets outside, 25 upon 16 here, and here also 16 gets outside, 25 upon 16. Now coefficient of s square becomes 1, and that is the standard formula for cos hyperbolic, because s is there and it is for sin hyperbolic. And we have to calculate a angle here. What is angle? This is a square according to formula. That's why we have to take square root of that number. What is the square root of 25 upon 16? That is 5 upon 4. This way answer for this is 4 4 the 16, 1 by 4 into cos hyperbolic this root 4 by 5 by 4 t plus this 15 by 16 as it is, and it is a sine. For sine, outside of the sine hyperbolic 1 upon a is there in the formula. That's why 1 upon a means this number's root. This number root is 5 by 4. That's why 1 upon 5 upon 4. In next time 4 will be come to numerator. Sine hyperbolic same number 5 by 4 t. That's why 1 by 4 cos hyperbolic 5 by 4t plus take 1 by 4 constant outside common. You can skip this step also. This is our final answer. Okay, now these are some homeworks for you. These are 4 homeworks depend on the earlier we have just seen the examples. Now in this example you have to expand this square and separate out the numerator. Answer is this. In this step also separate out the numerator. This is also same, this is also same. In this example you have to take after separating the numerator you have to take 9 common like this. How we take 16 outside common, like this you have to take 9 outside the common, because we have to make s square coefficient 1 for our standard formula. Now these are the just normal formulas we have just seen. Now let us see the first property of inverse Laplace transform, that is first shifting property. In Laplace also we have seen such exponential property. Here also exponential property is there, that is called first shifting property. Let L inverse of phi of s is equal to u of t. In Laplace transform our original sentence for each property was let L of ft is equal to phi of s. Okay, in this chapter our first assumption will be let L inverse Laplace transform of some function, that is phi of s, is equal to the answer in TL again. That's why it is equal to f of t. It is any function. It is our basic assumption. Then inverse Laplace transform of phi of s minus a is equal to, if we know this we can calculate this by using this property, and the value for this is equal to e raised to, this number we can take outside as exponential, e raised to, if minus a is there we have to take plus a, if plus is there we have to take minus a. That's why property is e raised to at, L inverse as it is, and what we have to do, just delete this minus a. That's why it becomes L inverse of phi of s. Okay, let us see some example depend on this property. 17th example, we have to find out L inverse, that is inverse Laplace transform of 15 upon s plus 4 bracket square. Okay, this example we cannot solve using earlier method. Okay, because denominator contains square, right? That's why we have to use this property, because in this example is this function wherever s is there, here in denominator only s is there, s plus some number is there, or if some s minus also is there, even minus is there, then also we have to use this property. Then this plus 4 can be take outside using this property. First let us see. First we have to write the property, let n inverse of phi of s plus a, if plus is there you can write plus property for plus sign, and you can write minus a property for minus sign also. Okay, is equal to e raised to minus 80 L inverse of phi of Yes, this is the property. Here A is equal to, in this example, 4. That's why L inverse of 15 upon s plus 4 square becomes 15 is a constant, take outside, L inverse of 1 upon s plus 4 raised to square. Now this 4 can be take outside as e raised to minus 4 t. Don't forget this t. And L inverse, rest of the terms, what do we have to do then? Just delete this plus 4 and rest of the terms as it is. That is 1 upon s square. This is the exponential property or first shifting property. And what is L inverse of 1 upon s square? This is the standard we know, t raised to 2 minus 1 upon 1 factorial. That's why answer for rest of the terms as it is. And final answer is 15 t e raised to minus 4t. Okay, this is called exponential property or first shifting property. Now let us see this 18th example, L inverse of 1 upon. Now in the denominator it contains quadratic function. Whenever quadratic function is there in the denominator, raised to power only 1, then in the denominator we have to adjust the square. Okay, like for example here 1 upon s square plus 4s plus 5 is there. We have to find out which square, bracket square, can be adjusted here. Okay, how to find out? Let me tell you the thinking behind that. For example, this is, we know it is a plus b bracket square is a square plus 2ab plus b square. If we given this, we can easily expand this because it is a original formula. Now we have to think in a reverse manner. That means if we are given this or this, only two things, we have to find out the perfect square number. How to find out? This is the perfect square of this number, we know that. Now in the reverse way, this is the first term square. Okay, this square means this is the first term square, second term square, and in the between 2 times first term into second term is there. That's why it is the perfect square if we want to prepare. Okay, it is the perfect square, obviously it is like this. And what is the middle sign? It depends on the this sign, middle term sign, because a minus b bracket square is nothing but a square minus 2ab plus b square. Only difference between these two is this sign. That's why if this the middle sign is plus, we take plus square. If middle sign is minus, we take minus. Okay, now in this case the middle sign, how we define what is the middle term, how we calculate that, how we decide that? Because in middle term no number square is there. Okay, only first number, second number, any number and two number is there. That's why in this example, or if we want to take reverse thinking, this a square means this is a first number. Okay, and middle sign is plus, that's why it is plus. And how to find out second number? Using this middle number only. Middle number is 2 into first number into second number. If you want to find out for second number, we have to find out the middle term, and whatever the coefficient of first term is there, we have to just divide that number by 2. We get the second term. Okay, in this case this is a general example, that's why it is b. Let us see this example. In our example here, s square plus 4s plus 5 is there. That means it is a first number square. That's why it is, yes, should be first number. And first number is present here. That's why it is of course the middle term. That's why middle term sign is plus. That's why it is plus square. Okay, plus square. And how to find out second number? Here in the middle term 2 is there, first number is there, and second number is there. Now here is 4, and already yes, this is the first number. In 4 it consists of second number including 2. That's why whatever the number present here with the coefficient of es, we have to divide that number by 2. It's just as simple as that. That's why 4 divided by 2, whatever it is the number, just divide by 2. What we get? 2. it is a perfect square of s plus 2 bracket square. If it is minus, we have to take minus. Okay, now let us see how to adjust the number. After that, here the perfect square can be adjusted by s plus 2 bracket square, but it is not the s plus 2 bracket square. We have to equalize that. That's why we have to find out which number we have taken additional. That means here, for that, just think a reverse way. Now expand this bracket. What is that? A square, that is s square is there, plus 2ab, that is 2 into 2 into s, that is 4s is also there, and last number 2 square in every example is not there, that is plus 4 we have taken extra. That's why whatever we have taken extra, we have to subtract it from the remaining term. That's why 5 minus this 4 becomes 1 remaining here. Understand? That's why it is become equal now. We have adjusted the one square here. Okay, and whatever number we have taken extra, we have to subtract it from the given number in the denominator, whatever number present in the denominator. That's why it becomes 1 here. Now we can apply everywhere. We have to use by first shifting property. We have to write here. Okay, in this notes I am not written, but in sections or assignments you have to write every property in between the sentences. Okay, here first shifting property, which property? You have to write this property. Okay, now first shifting property, apply this first shifting property. It becomes this, wherever s is there, here s is there, s plus number is there. That's why this plus number, plus 2 number, that we can take outside as a exponential e raised to opposite minus 2t. And rest of the terms, what we have to do, just delete this plus 2 number from each term. That means it becomes L inverse of 1 upon s only here, s square plus this as it is 1. This is called first shifting property. And this is the L inverse of 1 upon s square plus 1 is a standard formula, that is sine 1 square root, that is 1t. Okay, e raised to minus 2t sine t. Now consider next example. 19th example, L inverse of s upon s plus a bracket square. Now here in this example, s plus a is there, it's okay, but in the numerator also s is present. That's why to use this first shifting property, we have to adjust that number everywhere wherever s present. Now here s plus a is there, we don't need to adjust here, we have to adjust this plus a in the numerator. Okay, that's why s plus a and of course minus a, it is an adjustment. Now if you observe this, wherever s is there, s plus same number is there. That's why we can use, by using first shifting property, you have to write property here. We get e raised to this plus a as a minus at outside, and L inverse of, you have to just delete this number, that is s minus a upon s square. Okay, this is called first shifting property. Now this is very easy, just separate out the numerator. We get s upon s square minus a upon s square, and this is s gets cancelled, 1 s remaining in the denominator. Now take L inverse inside, rest of the terms as it is. L inverse of 1 upon s, this step you can skip, minus L inverse of, that is a, take outside because it is constant, L inverse of 1 upon s square. 1 upon s inverse is 1, and 1 upon s square inverse is t raised to 2 minus 1, that is 1 upon 1 factorial, that is 1. Answer for this is 1 minus at into e raised to minus at. Okay. Okay, consider now next example. We have to find out 20th example, L inverse of s plus 3 upon s square plus 6s plus 13. Now here again denominator contains quadratic factor. First you have to concentrate on denominator. Then accordingly whatever the number we adjust there, ultimately though that number should adjust everywhere, in the numerator, in the denominator also. Now in denominator it is a perfect square, we have to adjust. Which number it is? Obviously it is s square, that is it is first number, yes. Middle sign is, this is plus, obviously plus, and this first number, that is yes, and we have to find out second number. How to find out? Just divide the coefficient of yes by 2, that is 6 by 2 is 3. Okay, this is yes plus 3 bracket square we can adjust here. Now we have to subtract that number which we have taken already extra from this square. Now expand this a reverse way. A square, that is a square, plus 2ab, that is 6s is there, and last number 3 square, 9 is not there. Plus 9 we have taken extra, that's why we have to subtract 9 from remaining 13. 13 minus 9 is plus 4. Okay. Now if you observe this, everywhere yes plus 3 is there. That's why we can use property right here, property. Okay, in the assignment also everywhere yes plus 3, yes plus 3 is there. That's why by using exponential first shifting property, this plus 3 can get outside, e raised to minus 3t, and L inverse of this, delete this plus 3, we get yes upon s square plus 4, and this is the standard formula for cos 4th root 2t. Okay, now consider the second. 21st example. L inverse of s plus 2 upon s square minus 4s plus 13. Now in the denominator, already in earlier example, s plus 3 gets adjusted, and there is already a plus 3 is present here. That's why we don't need to adjust plus 3 in the numerator. Okay, already it is present, but it is not necessary which is the number is already present in every example. That's why we have to adjust in numerator also whenever that is there is needed. Okay, L inverse of, now we have to find out s plus 2 upon s square minus 4s plus 13 here. Okay, now concentrate on denominator. What is the perfect square of which number? It's s square, that is yes. The middle, this is the middle term because it contains the first term, and it is minus, that's why we have it a minus in the bracket. Minus expansion is there. And what is the second number? How to find out? The coefficient of first number, that is coefficient of s divided by 2. 4 divided by 2 is 2. Okay, now which number we have to take extra? We have to find out. Now expand this. A square, that is a square, minus 2ab, that is minus 4s, and plus 2 square, that is plus 4, we have taken extra. We have to subtract it from 13. 13 minus 4 is obviously 13 minus 4 is 9. Okay, now here what denominator contains now? Yes minus 2 is there, and in the numerator yes plus 2 is there. Whatever the constant doesn't matter, we have to concentrate on yes for first shifting property. Here yes get adjusted with one number, that is yes minus 2. With the same number every yes should be adjusted. That's why in the numerator here we have to take yes that number. Just it is simple, what we have to do, just take that number with addition and subtract it from the numerator, or if it is minus, just take minus. For example minus 2, we have to just add 2. Okay, that's why to adjust here minus 2 we have to take like this, denominator as it is, yes minus 2 we want, and ultimately we have to cancel this effect by taking plus 2. Okay, and this 2 as it is, which is already present in the original example. Okay, that's why above equation becomes yes minus 2, 2 plus 2 is 4, and yes this is denominator as it is. Now if you observe this, everywhere two terms are there of yes, and yes minus 2 are there, 2 is there. That's why we have to take use first shifting property. You have to write here first shifting property in detail everywhere. We can take minus 2 outside as a plus 2, e raised to plus 2t, and L inverse of, what we have to do, just delete this minus 2 everywhere. We get yes plus 4 upon s square plus 9. Okay, this is the only important step. The rest of the terms we have already done. That's why now we have to find out this inverse. Just separate out the numerator. We get s upon s square plus 9 plus this 4 take outside, 1 upon s square plus 9. This is obviously cos 3t, 9 root is 3t plus 4, and this is obviously sine. Outside the sine, 1 upon a is there. 1 upon a means 9th root 3, and sine same number 3t. This is the formula, original formula. This is the answer. Okay, more simplified answer. Now let us see this example. L inverse of 4s plus 12 upon this denominator. Now concentrate on denominator. S square plus 8s is there. That's why which square we have already 16 is there. If you observe, this is a perfect square of s plus 4 bracket square. We don't need to adjust anything. This is a perfect square only. Okay. Once square gets adjusted in the denominator, same number we have to adjust in the numerator. Which number? S plus 4 is there here. That's why we have to take s plus 4 here. Okay, now which number we have taken extra, we have to calculate that is here 4s, and 4 4s are 16 we have taken extra. That's why we have to subtract 16 here. Okay, and plus 12 it is already present in the example. That's why this is our adjustment for the square quadratic term. Now here calculate this 6 minus 16 plus 4 is minus. This is as it is 4s plus 4, and minus 16 plus 12 is minus 4, and denominator as it is. Okay. Now here if you observe this term, s plus 4 everywhere is there. That's why we can use here property, write down first shifting property. We can take plus 4 outside as e raised to minus 4t, and L inverse of just delete this 4. Rest of the terms as it is, just we have to delete this 4. That means 4s minus 4 upon s square. Okay, now this is very easy. Just separate out rest of the terms as it is. Separate out the denominator, numerator. We get 4 upon s gets cancelled. 4 by s minus 4 upon s square. Now you can skip this term step. You can directly write this 4 as it is. 1 upon s inverse is 1, and L inverse of this 4 get outside, and this 1 upon s squares inverse is t raised to 1 upon 1 factorial. Now take 4 common from the bracket, we get 4 e raised to minus 4t into bracket 1 minus this t remaining. This is the most simplified answer for our question. Okay, now in this way we can adjust squares in the denominator, and that number also should adjust in the numerator, and in that way we can use the first shifting property to find out inverse Laplace transform. Okay, now this is the homework for you, where you need to solve this using this step only. These are the examples, reference examples. Now consider next example, 24th example. We have to find out L inverse of s plus 1 upon denominator contains s square plus s plus 1. Okay, this is a special example. Okay, this is the only example where fraction is there. Now we have to adjust square obviously here. Which square we have to adjust? This is per first number square, that is s, plus second number we have to divide the coefficient of s by 2. Coefficient of s is 1, divided by 2 means 1 by 2 will be the second term. Fraction is there. Okay, half square can be adjusted here. Now which number we have to take extra? That have to subtract from the original number. Then expand this reverse way. A square, that is s square, plus 2ab, that is s, 2 into half into s, that is s, and last number is 1 by 2 square, that is 1 by 4 we have taken extra. That means we have to subtract 1 by 4 from 1. Directly you can write 3 by 4 here, but it is fraction. That's why write down this one more step extra, doesn't matter. That is we have to subtract minus 1 by 4 to cancel this effect. Now originally 1 is present already, that as it is. Okay, now this is the adjustment we have done in the denominator. Now 1 minus 1 by 4 is 3 by 4, rest of the terms as it is. Now here already denominator s get adjusted with the quadratic expansion. Now same number we have to adjust in the numerator. That means in the numerator also s plus half is there, but in this case what we generally do, plus half minus half. But in this here 1 is present, that's why we can split this one as half plus half. In this way also, depend on the number, you can do the shortcuts. Now s plus half plus half. Okay, now here if you observe, denominator is same, s plus half is everywhere there. That means you can use here exponential or first shifting property, that half number can be take outside as e raised to minus half t, and L inverse of what we have to do, just delete this half everywhere from s. That means here s plus half and upon s square plus 3 by 2 is there. Okay, here this is the most important step. Now this is a very easy example. Now separate out the numerator. We get s upon s square plus 3 by 4 plus half upon s square plus 3 by 4. Now take L inverse inside and ultimately half or constants gets outside. What we have here, e raised to minus t by 2 minus half t means minus t by 2. Make curly bracket, bigger bracket. L inverse of first number is this, second number half gets outside, which is a constant. Now this is a very simple, whatever the number it is just a number. Don't forget that it is just a number. Okay, we have to concentrate on s function. S square coefficient must be 1. Okay, and this is a cos and this is obviously sine. That's why it is cos root 3 by its root. Root 3 by 4 root is 2 t, plus this is sine. That's why outside of the sine 1 upon a number is there in the formula. That's why we have to take 1 upon a. What is a? It's root 3 root 3 by 4 root is 2 into sine, same number, root 3 by 2 t. Okay, in the next step this 2 gets in the numerator, cancel with this 2, we get the final answer. Okay, this is the most simplified answer. Now here some more homeworks for you are there. These are 4 homeworks, depend on the adjustment property. Everywhere hints are given, everywhere answers also given. Okay. Okay. Now here we are going to see the first method of inverse Laplace transform, that is method of partial fraction. Okay, partial fraction consists of numerator and denominator contains multiplication of brackets, and depend on the bracket or depend on the nature of the brackets, we have to decide in which type that example actually we have to solve by that type. And there are only 3 types for method of partial fraction, which is very easy method in this inverse. Okay, let us see the types first. Here type number 1, if phi of s, that means given example is of the form like this, where denominator contains linear factor. Here linear, these are the linear factors. First step is for linear, type 2 is for linear repeated, and type 3 is for quadratic factor. Okay, now in the first step, in the type 1, if suppose denominator contains multiple of brackets, it can be 2 brackets, 3 brackets or 4 brackets. In the example they can give number of brackets. Suppose for contrary, consider there are suppose 3 brackets which are linear. What do you mean by linear? Where variables indice is 1. Here variable in this chapter is yes, and everywhere s raised to 1 is there. That's why these are called linear brackets. And what do you mean by there are only 2 brackets, linear or quadratic. Quadratic means quadra means 2. Quadratic expansion we just know. Quadratic means square. Okay, where s raised to 2 is there. Now here in type 1, suppose every term is linear brackets are there, then the first step will be we have to write this given example or expression of s as a upon, we have to assume the constants capital A, capital B all the capital numbers are constants. How many brackets are there? Suppose here 3 brackets are there, that's why we have to assume 3 constants, that is a, b, c. And first step will be, you have to write the expression like this: a upon first factor plus b upon addition, throughout the take addition, b upon s plus b plus c upon s plus, suppose this is d, okay, we have to already use c, yes, c upon s minus d. We have to write in this fashion for type number 1. What we have to do after that, we are going to see in the example itself. Now type 2 is for linear repeated. Repeat means that factor, if suppose particular factor is repeated. Repeated means multiplication of brackets, means square, cube. Suppose this is the example. Suppose there are s plus a, suppose this is a factor repeated 3 times, means cube is there, square is there, raised to 4 is there, like this. This is called linear repeated type. And suppose s plus b is first type, yes, repeat once only. That's why for this type, the phi of s given function can be written in this fashion, means it is repeated 3 times. That's why we need 3 constants, and this plus 1 constant, 4 constant we have to need here to write this factor in terms of addition of factors, like this: a upon single s plus a plus b upon s plus a square plus c upon s plus a cube. Whatever the number here, we have to repeat like this only. Okay, if suppose raised to 4 is there, we have to add one more expression, that is d upon s plus a raised to 4, depend on the factor how many times it get repeated. Okay, and this s plus b is not repeated, that's why the type 1 rule is apply here, that is plus next constant d upon s plus b. Okay, this is type 2. For first is linear, every factor is linear. Second is for linear repeated factor. Now third is for quadratic factor. Suppose one of the bracket or every bracket is quadratic. Suppose these are two quadratic factor. For quadratic factor, you can write this function as as plus b. This type of term you have to write for this factor, first factor, as plus b upon first factor, plus now second factor, cs plus d upon second factor. Suppose one more term is there, then ef plus f we have to write out like this only. These are the first step or rules for writing the partial fraction. This is called method of partial fraction. Okay, now in next lecture we are going to see the proper examples depend on partial fraction. Okay.